let's get into the hardware first for you guys. The Pascari Enterprise X series. So this is a product line that is all about high performance, different market segments, AI, machine learning. We're going to talk about that here in a minute, but you guys are actually going to talk to me about that. High performance computing, databases, hyperscale data centers, that sort of thing. So my natural progression through all this is always going to be speeds and feeds, because that's where I came from. So I'll have to go and work to tone some of that down to talk about system solutions and that sort of thing. But before we do system solutions, let's talk about Pascari. So 14.8 gigabytes per second. We have to be kind of conservative with that number because it has to go across all platforms. We did send some review drives out to media, and it's very easy to reach 15 gigabytes per second. This is the only enterprise SSD on the market that can do that today. 8.7 gigabytes per second. There's a typo on there. 8.7 gigabytes per second on the writes, and then 3.2 million IOPS. Read 930,000 IOPS, right? This is the fastest enterprise SSD on the market today. PCIe Gen 5x4. It is a dual port design. You can also get it in a single port.
I'm assuming this is TLC.
Yes, this is a TLC product. It comes in U.2 and E3.S. There's a number of them up here. So 5-year warranty, very low latency, 128 namespaces. It's got all the bells and whistles, essentially. So I do want to ask you guys a question, because you've had all this AI time and all that. The question is, how has AI changed data center workloads? Has anyone talked about that over the last couple days?
No.
I think we've talked, that's a lot of what we've talked.
Well, tell me, does
I
anyone
think the
want
answer is it depends today. Today, it depends on the company, what the company does, and how big they are.
Okay.
I mean, if you're talking about small to medium companies, then they're looking at how is this going to change the world. They're worrying about how it's going to change their data center workload or their cloud strategy, et cetera. If you're talking about larger companies, healthcare companies that, use it for, looking at your scans and evaluating those, then they're already looking at the cloud, and they're using the cloud and looking at, do we bring this in-house? So, and then, of course, you got the big one.
HIPAA.
Yeah, HIPAA regulations.
Plays with that cloud stuff.
Yeah.
Yeah, I'd say, this is Brian, Signal 65. If you're training, massive sequential write bandwidth. If you're inferencing and you're inferencing batching or a lot across a number of models, you want massive read bandwidth. Those are the big shifts I've seen.
Yeah. Anyone else?
For me, Karen.
Hi,
For
Karen.
me, it's added new workloads. So it's not just increased data volume or anything.
Yeah.
So it reminds me a lot as we went from mostly transactional data to analytical or data warehouse data. New workloads, new copies of the data, even though we don't like doing that. So from my point of view, it's a lot of the same problems we had just with high performance things that we needed and data volumes. But in this case, I think it's a lot higher and a lot higher needs for all of this stuff. So it's a blip in the demands for everything.
Well, I think another thing that we've talked about but really haven't addressed a whole lot is that we end up with much longer running jobs.
That's a good point.
Jobs that have to run continuously, that can't stop in the middle.
Okay. So let me go on and kind of give an answer. This is from one of the reviewers that wrote an article the other day. So prior to AI revolution, data centers SSD's normal operating range would typically never exceed QDEP 32.
What's the QDEP 32?
Yeah, QD 32.
But what is that?
Oh, what's the QDEP? Let me finish reading it and I'll tell you. With the AI data pipeline storage being directed by the GPU, essentially GPU directly talking to the SSD instead of through the CPU and the DRAM, high queue depths are now becoming paramount. Queue depths in the thousands are now commonplace. So essentially on your computer, are you using Windows? Okay, you know, when you go to your task manager and you see all those hundreds of things running,
Right.
when those reach out to your storage, it's doing it. Each one is doing it, you know, one queue depth at a time. So each one, it's a single contact. With enterprise workloads, you get multiple things happening at one time. So that is a queue depth. So 2 calls, 3 calls, all happening at the same time. And the drive will prioritize that data through something called native command queuing. So the system and the drive will monitor that, the incoming requests, the outgoing requests, and prioritize, put them in order. And for traditional enterprise workloads, you've got so many drives, say 24 drives in a system, and we'll actually talk about this here in a minute. So the queue depths are relatively low. Now you've got data centers with thousands of GPUs hitting 1 or 2 storage boxes, and each GPU actually has, like some of them are 16,000 and above tensor cores in there that can all reach out back to the storage directly. So that will increase the queue depth performance. Now, why does this matter? This is a generational breakdown from our X100 to our X200. So the PCIe Gen 4 model, the outgoing model that's actually still selling really well, and our new PCIe Gen 5 X200. It's driving me nuts, I can't walk over there. So at low queue depths, we went generationally a 700% increase at queue depth 1. Now, this is more for the legacy workloads, the non-AI, because when you throw 24 drives in a system, each drive at queue depth 1, the system is queue depth 24. So essentially, this comes to your sustainability question from before. What are we doing for sustainability? The server can go and run more tasks with less power and do it faster. Both of these drives here, they're limited by PCIe SIG at 25 watts. Neither one of them are at 25 watts, but they're limited there. So we have more than doubled performance and still kept within the power spec. They both run about the same wattage. So we covered sustainability on this part. Now, going over to the high queue depths, there's a 60% increase. So this is where I can tailor kind of this message to AI. And you can see where the next generation product really flourishes with this new workload type that's emerging. So I did say earlier that the X200 is the fastest enterprise SSD available today. We've got independent testing that's backing that up. A lot of people like the speeds of feeds, especially at very high queue depths. We outrun everyone else. This is an image pulled from one of the review sites that published the reviews, published the X200 review. And then there's more coming online here in the next few days from other sites. Are you guys familiar with what this chart represents and what's going on here?
Oh, yeah. That's my life.
Anyone have any questions on it? You want to?
If you just want to give a broad overview.
Yes,
I mean, I
please.
know it, but for some people who don't understand it, obviously.
Yeah.
Okay, so this is a
Yes, please.
This is a 70-30 workload, so it means it's 70% reads, 30% writes. This is, it's actually kind of odd because it's the traditional database workload, but it also carries over to AI too, almost 1-for-1. Lots of reads, figure out the data, digest it, and then send back what you need to the drive. So it's almost at 2 million IOPS at a high Q depth, at Q depth 128. So just the simple takeaway with this one is it's really fast.
That's all I needed. Thank you.
So, any questions about anything so far?
On the previous slide,
Yep.
you know, what's the limiting factor that's keeping the right side of that chart from plateauing at the limitation? You can see the previous generation is hitting the Gen 4 limit. That's why the line is flat.
Mm-hmm.
Do you know what's throttling the new X200?
Well, this is also 70/30 workloads.
Mm-hmm.
So theoretical limit is actually for Gen 5 because it's
Be
mixed.
16. Yeah.
Well, no, because PCI Express is bidirectional.
Mhm.
So it's technically 30-ish. So at that point, you're looking at things like background garbage collection, NAND management, that sort of thing. That
Power
kinda-
throttling?
Power throttling is a thing because remember we're still limited to 25 watts. If you guys have some pull with JDEC and PCI SIG, help us out there.
Which is the 35. Thank you.
So now let's talk about application side for those of you that covered the boxes and the companies that put it all together. So we actually brought one of the VDURA systems with us. You were talking about wanting to see the inside. We'll make sure to get you the deck, and we'll pull this cover off here in a bit. So this is the VDURA V5000. The system holds 12 U.2 NVMe SSDs in a 1U form factor, which of course is 1.75 inches. The system, right off the bat, is going to ship with 30.72 terabyte drives, similar to this. And then, of course, from the previous generation, those drives were limited to 16 terabytes, so 15.36. So right off the bat, you got your doubling performance. Later on, when they become available, the next generation is 122 terabytes. So let's go back to the sustainability part. You're going from 32 to 122. You're still using the same power. You're still hit with that 25 watt limit, and you've got the same power at the server level.
Yeah. Given the relationship with VDURA
Mm-hmm.
and the past and the relationship that you had with those people at Seagate, is there any customization of your drives that is going to VDURA? Did they customize anything, or are they taking it what you have and putting it in the box? Because I know they've redesigned the architecture of the hardware and everything else over there. So
I'm not sure how much I can say about that.
So the answer
I wear
is
a lot of
yes.
hats.
the answer is yes, that you did some design with them. You don't have to say what, but
Okay, yeah. I'm getting a thumbs up from back there. Because I'm also on the team that does like performance testing and all that.
okay.
If you know my background, I was a reviewer and very hardcore into testing.
Yeah. Okay.
So when we work with a company like VDURA, obviously we send them drives.
For you guys who
and
don't know,
they-
VDURA is the old Panasys company.
I'm sorry, say that again.
Panasys.
Panasys, thank you.
The renaming of Panasys, which is a high
Thank you.
parallel file system.
Yeah.
Okay, go ahead.
So we send them drives, they test it, they've got their own proprietary things, we got our own proprietary things. And they'll say, well, you know what, can you do something a little bit different over here on the performance side or a certain feature? And with a company like VDURA, yeah, we'll easily go and take on those challenges and do that for them. Of course, Michael's talked a little bit about Imagine Plus. The difference between working with us and some of the competitors, because everyone can do some type of customization work. You go to HP and you pull out a drive, it'll say one company name on it. like a big storage company, and then it'll say HP underneath. There's some customization there. The thing with Phison and Pascari, you don't have to do it in as large a volume to come to us. Right?
Okay.
So, yeah, VDURA is definitely large enough to get that custom service. And we do a lot of back and forth. There's a lot of meetings between Phison, our Broomfield office, and VDURA to get everything exactly how they want it and how they need it. And for Phison's part, we're trying to make their products better, and at the same time, we're able to make our products better with that collaboration. So the Pascari data center, the D-series. So essentially, data's growing. We all remember the old data deluge message from about 10 years ago from companies. That's never stopped. So we've got these massive data centers going up. The new Pascari D-205V brings the market to 122.88 terabytes. Essentially, it's a 128 terabyte drive. It's a 400% increase from before. Rip out your 30 terabyte drive, put in the new 122. You immediately get a 2.2 petabyte increase at the server. At the rack level, it's almost 60. It's going so fast. At the pod level, with 12 racks, 707 petabyte increase. The stars part, we'll talk about a little bit later, and Michael mentioned some of our outings into space. I don't know if he talked about Mars, but we've got some stuff on the rovers as well. That's the D-205V. There's also the D-200 class, which comes in several different form factors. This one here being one of the growing popular ones. The funny thing, this is called E1.S, and there was only a couple companies at first that really utilized this. This has been around for maybe 10 years. And no one really wanted to adopt it, but now with AI and the form factor changes, this is making a comeback. So once what was old is now new again.
How thick is that? Because I know that little one looks like a stick of gum.
Yeah, so this is 22 millimeters by 80 millimeters. And these are actually, the stick of gum form factors come in 22 wide by 30, which is really tiny, 42 and 80. And then in the back, we've got some 110 millimeters long. Off the top of my head, I really don't remember.
Is that like twice this thickness, 3 times the thickness of that? Okay.
3 maybe?
Oh, it's easily 3. I would say that's 7 millimeters, 6 to 7 millimeters thick. I'd have to look. It's not one of those things I remember anymore.
But is it as thick as the other ones, the ones you were just showing?
Yeah, so this one here, that's a 5 millimeter. So yeah, this is 7 millimeters. 7 millimeters thick.
There are a lot of form factors of all different shapes, types, and shapes and sizes. That's what.
Yeah, well, that's the format wars. It's Sony versus Panasonic versus Beta, all that good stuff. So, D200. This is a PCI Express Gen 5 class, like a lot of the other products we've shown today. The real beauty here is you've got the different form factors we've shown here on the screen. There's mainly the E1.S. Performance-wise, it comes in 2 flavors. The E versions of the drives are 3 drive writes per day, and that gives you increased write performance as well as endurance. The trade-off is you lose some capacity. So these would be like a 6.4 terabyte product. On the P version, it would be a 7.68 terabyte version. They both have the same read performance, 14 gigabytes per second, 3.3 million IOPS. But when you take control of the flash back, you go down to 1 drive write per day. And for most workloads, that's completely fine. It's only when you get into the extreme database stuff, very high write endurance is where you want the 3 drive writes per day. Oh. And then we already talked briefly about the D200 and D205 with the video. The 200 version goes to 61.44 terabytes, which until just a few months ago was amazing. And then we've had the launch of the D205 that now takes it up to 122 terabytes. Again, sustainability, they all run at the same power limits. So essentially what it comes down to is your OPEX cost, right? You're not going to add on to your server or your server farm, because building that up, you're just going to build a new one. By going to these larger drives, you can just put in more drives, stay with the same amount of power, but increase your density, your scale for the storage. So briefly, I want to go and talk about some of the legacy type stuff that Phison does. The B-series are boot drives in the SATA series. Like for instance, NAS products for consumers are still mostly using SATA drives, either SATA hard drives or SATA SSDs. Phison offers a 16 terabyte SATA drive. There we go. But I guess we'll go boot series first. So boot series, every server in the world like this, as painful as it is, it still needs a boot drive. So a lot of companies, you'll find that they're going to go and put, if they try and do it low cost, they'll put like a consumer or client drive in there. But that's not really ideal for the data center. The big data center guys will seek out a very specific drive for this purpose. And Phison offers that, and we actually specialize in this. For the SATA drives, the legacy market, if you go back, the most popular SATA SSDs actually were about 2 terabytes, right? But when you want to get into mass storage now in 2025 and take your NAS to modern levels of data ingest, you can buy a 16 terabyte or 15.36 terabyte SATA drive, rip and replace for your home NAS or your company's NAS. Oh, I double tapped it. So there's only 3 takeaways that we want you to have from Pascari today, and that's our broad portfolio and deep expertise, the legacy products that we're going to keep around, the new generation, all these different form factors that we're going to support going forward, and that we support today. Trusted innovation partner, vertically integrated with our IP, our controller knowledge, our testing, the different labs, unmatched flexibility, reliability, and performance across hyperscale AI legacy systems. And then finally, the proven in space, but built for Earth. A lot of work really does go into making just a few drives that go into space. And a lot of that knowledge does go and kind of trickle down. It's kind of like racing. You got the race car, and then some of that stuff trickles down. So, any questions?
What about the weight of the drives? Is that something that keeps going down?
Actually, no. It fluctuates depending on lithography notes and stuff like that. Like the very first SSDs, like ones like this, weighed more than these drives. When you get to lithography nodes that run cooler, You can make them in thinner cases because you don't need to provide as much cooling. And then when you're on the other side, kind of the tick-tock, like one company used to have, you get into making the cases a little bit heavier for heat dissipation.
I know some systems in the past with a lot of drives. I mean, take 2 or 3 people just to pick up the boxes.
If I'm going to be a bit snarky here, yeah, the key takeaway for me was, of course, that you make SSDs. But what was really interesting there is the way you do that, the validation and the approach, which, you know, as a colleague of mine said here, if you're doing 70% of the organizations working in R&D, I think that it kind of shows in the way you design your products and so on. But and maybe I will just tie it back, not just with the whole story here about the form factors that you have, but with what was shown before. One of your colleagues was showcasing the way you do, you know, what you're doing with the AI product, AI active thing that you were showing before. And it was interesting in the sense of, you know, the market you're trying to address here. You know, we talked here about the large ones, and these are kind of things sorted out, but those smaller ones need be some help in there. So, yeah, that's it for me. Thanks.
Yeah. That's great feedback. Thank you.